Okay, hi guys. Today we're going to be working on ellipses. So we're going to talk about our ellipses. Depends on who you're talking to, how it's pronounced. Ellipses. Our objective is 1.2c. We are going to define what is an ellipse. We're going to find its vertices, plural for vertex, covertices, plural for covertex, and foci, which is plural of focus, of an ellipse. So, and then we'll write an equation of an ellipse in standard form, and we'll graph it. So our vocabulary today: an ellipse, foci, major axis, minor axis, vertices, covertices. And we'll draw pictures of all of those so that will help you to understand what those terms are. Now, an ellipse is like a circle. It's just been smushed. Okay, so what is an ellipse? Is a circle that's been smushed, right? And so it has, it basically has a long diameter and a short diameter, and then a lot of diameters that are in between. Okay, so ellipse is a locus of points, right? So it's just a big collection of points, so it'll make a curve for which the sum of their distances from two fixed points called foci. So now we have two focuses, but proper grammar would be foci, and the distance, the sum of the distances from that point to those 2 points is constant, meaning it never changes. And that's kind of hard to understand. If you wanted to, you could go watch a video of an animation of how an ellipse is located. So for example, let me draw an ellipse here and just straighten that up a little bit, give myself a little more room. Okay, so here we have our major diameter, or our major axis, okay? And this will be our minor axis here. Okay, and these aren't actually part of the graph, they're just distances, so I'm going to go clean those up. All right, and the foci are always on the major axis, right? So this would be our focus and our other focus, so those are our foci. And we have vertices. Well, I'll talk about those next. Let's just call this here as the major axis because it's longer. It's also a major diameter. And this here is our minor axis, or some people call it your minor diameter. So just for future reference, this is called a major radius. This is called a minor radius. Okay? All right. So let me just help to illustrate this definition of an ellipse. I'm going to put a point here. So this is going to be point P. Now it says that point P is part of that locus of points, and the sum of the distance from this point P to each focus, so there's distance sub 1, and here's distance from that point to the other focus, this is distance sub 2, has to be the same as, let's say I put point S over here. So point S is really close to this focus, and it's pretty far away from that focus. So that would be a distance sub 3, because it's certainly a different length than the other distances, and this would be distance sub 4. But here's what's true. The sum of the distances from point P to both focuses, foci, is the same as the sum from point S to F plus point S to F sub 1. So the sums of those two distances, and it doesn't matter where I am on the circle. Let me see if I can move a point here. So if this point, let me see if I can do it, if it'll let me. I don't think it will. But say if this point moves over here, then this distance would move right here. And that would we just call this point S now. It would still remain the same sum. If you add their values together, they'll still be the same. So that's the definition of an ellipse. In fact, if you were to take like a piece of cardboard and put foci on the board a certain distance apart, and then you were to tie a piece of string to both ends, tie a piece, one end of the string here and one end of the string here, and put your pencil right here and keep the string taut. As you drag that pencil around, the figure that you would create would be an ellipse. You just would drag the pencil around. There's some really good animations online. I'll see if I have time to locate some, and I'll put them in the resources so that you can see how that works, or do a practice yourself. Okay, so that's the definition of an ellipse. Let me do some more illustrations. So what I'd like to do is just demonstrate or illustrate the other vocabulary here. So let's draw another ellipse. This time let's make one that's tall and skinny. That is not an ellipse. Let's try again. All right, one more time. We're going to go. We're going to get it this time. There we go. All right, so I'm going to straighten that up. I think I'll make it a little bit fatter. Well, this one is tall and a little bit skinnier versus this one over here was short and wide. Okay, so in this case, our major axis would be vertical and our minor axis would be horizontal. Okay, so here's our major and minor axes. All right, and our center is here, and usually your center is at HK, right? That's where your center is. And so up here at the top and the bottom of your major axis, these are your vertices. So this point and this point are your vertices. Okay, your vertices are on the major axis. The co-vertices, I'm going to put that here and here. These are your co-vertices. They're on the minor axis. And then your focus is located on your foci. Let's try that again. Those are located on actually that one would be F and this one would be F sub 1 because it's down below. These are your foci. Okay? And so foci, like I said, is just the plural of focus. Vertices is the plural of vertex. Okay? All right. And so you can use this information to help you understand a little bit better the vocabulary that surrounds or goes with ellipses. All right. So let's take a look at the standard equation of ellipse with the center at the origin. So we're going to start off basic, and then tomorrow I'll shift the center off the origin, and you know the equation will get slightly more complex, but I'm going to give you some tips to help you avoid the complexities as much as I can. All right, so here we go with the standard equation. It looks like this. If we're centered at HK and our axis, our major axis is horizontal, okay? So that's going to be x squared over a squared. The a squared always goes with the major axis, okay? Plus y squared over b squared. The b always goes with the minor axis. And all of these equations should equal 1. They should equal 1. Okay? This does come off of the equation of a circle, and I could show you that if you're curious about that. Here's something we need to make sure we understand. A has to be greater than B, and both of those things have to be greater than 0. Okay, so we're looking for positive values, and your A is happening on your major axis, and your B is happening on your minor axis. Okay, center will be at 0, 0, because there is no HK in this equation, right? I actually could write this as x minus 0 squared plus y minus 0 squared, right, to represent that. They say the same thing. So that just means that your HK is at 0, 0. Okay, we'll enter the more complex equation tomorrow. Okay, your vertices, I'll change colors here. Your vertices are going to be at negative a 0 and positive a 0. And remember, these are the endpoints of the major axis. And I'll do your co-vertices here in red. And your covertices are going to be at 0, negative b, and 0, positive b, or up b and down b. And these will be the endpoints of the minor. Minor meaning the smallest. Okay, major meaning the biggest. So that would be the endpoints of your minor axis. Okay, and we'll do your focus here in green. So let me try again, foci. So your foci are going to be on your major axis, right? So these are on the major axis, always. Foci are always on the major axis, and they will be at negative C0 and C0. Now, if you look at this equation up here, there's no C in the equation, so let me tell you how you're going to find it. Okay, to find C, we're going to use this equation. To find C, we're going to use C squared equals A squared minus B squared. And that'll help us to identify C. Then one more thing, your major axis is 2 times A. So that means that your major radius is A, all right? And your minor axis is going to be 2b, and your minor radius will just be b. So let's draw what that looks like real quick. So we're going to draw a major axis horizontal. So that means our ellipse is going to be long and short, like wide and short and fat. Okay, so we're going to go like this way. I'm going to straighten that out a bit. Okay, that's pretty good. Try to get it centered here on 0, 0. All right, so here's our center. Our center is always at the midpoint of your major and minor axes. It's just, you can find it simply by doing that. So this would be your 0, 0, which is your HK. And then let's see, let's grab a red blue pen here, and we're going to go this distance here, from here to here, to get to that vertex, right? Vertex is going to be A units back, so that's going to take us to negative A, still 0 on our Y. And if I go this direction, on our major radius A to the right, that's going to take us to this vertex here, which would be at A0. Okay? And then our minor axis is here. It's the shorter axis, right? So if we go up from here to here, B, we're going to go up B. Then we're at x equals 0, and we went up B units. So that's our minor radius there, up B. Our minor radius down B, that would take us to 0, negative B. Okay? Now, all we need to do is identify the foci here. So I think I was supposed to do that in red. I'm going to go back and recolor this in red real quick, because that was supposed to be red. And I just colored the ellipse in red, so now I'm going to select that and change it back to dark blue. Okay, there we go. All right, sorry about that. All right, so now I'm just trying to color code like I color coded up here. So now I'm going to go to the foci. So remember that the foci is on the major axis, so it's somewhere here. I'm just going to place it here for now. This is not drawn to scale. Okay, so this is going to be C units back, and this is going to be C units forward. And so this point right here would be negative C up 0, and this point right here would be at positive C up 0. And so there you have that. And you can see here that the distance of your major axis here, major axis is 2A. You can see it. That's 1A, that's 2A, so that's your major axis. Your minor axis, same thing, up and down. And your, oh my gosh, your, yes. So your minor axis is sorry about that. Your minor axis is 2B, right? Because there's 1B plus 1B is 2B, and then your minor radius is just B. Okay. All right, so let's go to look at our other equation. So if your major axis is horizontal, then the x, which is your horizontal axis, gets the a squared. And the y, which is your vertical axis, gets the b squared. If your major axis is vertical, those two things switch. So the equation goes x squared over b squared plus y squared over a squared equals 1, where a is still greater than b is still greater than 0. Okay, saying things that don't change. The center will be the same. To find c will be the same. Major and minor axis information will be the same. Okay, it's just the vertices, covertices, and the foci, they're going to do a little switching around. So your vertices in this case would be at 0. Let me go back here. 0 down A, because you got to go up and down because it's got a vertical axis it's a vertical axis, so that means it's going up and down. And 0 positive A. Okay, your covertices, those are going to be on your horizontal axis, and that's your B term. And so that'll be left B and right B, 0. And then your foci will be on your major axis. And so that'll be your vertical axis. So that affects your y coordinate. So that would be at 0 down C and 0 up C. And then all of this other information, the same. Okay? But now when we go to graph our ellipse, it's going to be taller than it is wide. So it's going to be long and tall and skinny. Okay? So it would look more like that. And I'm going to zoom in here so that we can identify. I'm going to grab my blue pen and we're going to look at our vertices here. So we're going to be going up A and down A. So we'll be at 0 A and 0 negative A, right? And our center will be here at HK, which is going to be 0, 0. And let's see, we'll pick my red pen up and we'll do the minor axes. So this is our minor axes here, the horizontal axis. So we're going to go back B and forward B. So this would take us to B up 0 and left B up 0, right? And then don't forget that your foci are on your major axis somewhere. So that's here and here. And the further away the foci are from the vertices, the rounder your ellipse will get until they center out, and then it turns into a circle. That wasn't a very good explanation. I can illustrate it with a calculator for you. All right, so there you have that information. Okay, so what's important here, let's just backtrack for a second. The decision, you have to make a decision. You have to look at the ellipse. You have to look for, actually when you're looking at the equation, what you have to look for is you have to look at where is the larger value. What is it under? Is it under the x squared? If it's under the x squared, then you have a horizontal major axis. If it's under the y squared, then you have a vertical major axis. Okay? All right. So that's the decision that you have to make. You have to pick the right equation. So let's take a look at example 1, and I fixed this on your notes, and also I'm going to fix these points here. So they're at negative 3, 0 and 3, 0. All right, so it says find the standard equation of an ellipse with vertices. Okay, so remember that the vertices, let me go back and color code here. Vertices are blue. Okay, so I'm going to go with blue. The vertices are on the major axis. Okay, they are. Right? And the center is dead centered between these 2 points. So I just like to go ahead and graph. So if the vertices are at negative 5, 0, and 5, 0, so that's my major axis here. And the foci, you'll notice, are also at negative 3, 0 and 3, 0. Those are both on the major axis. So let's go ahead and look at a couple things. Let's first decide what equation we need. Since the major axis here is horizontal, we are going to use the equation x squared over a squared. Okay, the a squared goes with the horizontal axis because it's the major axis here, and then y squared over b squared because it's going to be the shorter axis equals 1. And again, I'm choosing this one because the foci is on the major axis. Okay, it has to be. So there we go. So let's identify. We know our center's at HK, or at 0, 0, right? And if we go back this many units, what's our A? I think we can see that our A is 5 and negative 5, right? So we can see those 2 points there. So we know what A is. We also know what C is because our C is this value here in our foci, or you can see it. It's 3 units from your center. And so we're looking for our C to be 3. Okay? We know our center. It's at 0, 0. We know that because it's right in the middle of our 2 vertices. It's in the center, midpoint. Okay? So we know we have the right equation. We have A. We have C. What we need is B. So I gave you one equation, and it was this one, that C squared equals A squared minus B squared. And that equation will work if you have B and C and you're looking for A, or if you have A and B and you're looking for C, or in this case, if you have A and C and you're looking for B. So we're just going to plug in our C value, which is 3 squared, and our A value, 5 squared, minus B squared, and we're going to solve that for B. So that would be 9 equals 25 minus B squared. We'll subtract 25, and we get negative 16 equals negative B squared. Divide both sides by negative 1, and if you don't mind, I'm just going to rewrite that equation there. And then we're going to take the square root. Actually, let me take the square root of B squared and the positive and negative square root of 16. So our B will be plus n minus 4. So that means I'm going to go up 4 off the vertex, the center, and down 4 off the center. And so that helps me to graph it. Okay, that helps me to graph it. Now I just need to write my equation because I've identified my A, I've identified my B. Well, I guess we could go ahead and sketch the graph here. So I'm going to sketch my ellipse. Remember, it has to go through. That is not an ellipse. We're going to try that again. And that's a circle. 3rd time's a charm. Okay, I'll just squeeze it in here till I get it the way I want it. Anyway, let's go ahead and write the equation after you get your ellipse drawn. Oh, that's good enough. I'm calling it. Done. All right, so we have graphed it. Okay, all right. Let's write our equation. So we have our A and our B. So all we have to do is plug them in. So x squared over 5 squared plus y squared over 4 squared equals 1. And then we'll just simplify that to x squared over 25 plus y squared over 16 equals 1. And that's the equation. Now, I'm going to go ahead and take you to Desmos so that you can see that that's actually correct real quick. So we're going to go into Desmos, and we're going to type in this equation just to make sure. So x squared over 25 plus y squared over 16 equals 1. Let's get an equal sign in there. Equals 1. And there we go. You can see that I have vertices at negative 5, 0, 5, 0, and co-vertices at 0, 4, and 0, negative 4. And so there you go. Okay? We did it right. All right, so let's take a look at the second ellipse here. It says, so for the ellipse, 9x squared plus 4y squared equals 36. Find the vertices, co-vertices, and the foci. Then sketch the graph. Now, something that I'm realizing that I didn't mention before that I'm going to mention now is it's for a figure to graph an ellipse. You have to have an x squared. You have to have a y squared. You have to be adding them, and they have to have different coefficients. Okay, also, we want it to equal 1. So this is definitely an ellipse. We just need to simplify the equation. So we are going to go ahead and take 9x squared plus 4y squared equals 36, and we want to make it equal 1, not 36. So what we're going to do is we're going to divide everything by 36 and reduce this equation down to its simplest form. So that's going to become a 4, that's going to become a 9, and that's going to become a 1. So we have x squared over 4 plus y squared over 9 equals 1. So let's think about this for a second. Remember that a has to be greater than b, which has to be greater than 0. And 9 is greater than 4. Right, which are both greater than 0. So this means that I am going to have a vertical major axis because the larger values under my vertical stretch, my y-axis, right? And so this is going to be my A. So the equation I'm working with here is x squared over b squared plus y squared over a squared equals 1. So our job is to find the vertices, okay? So let's do that. Let's find A. All right, if a squared equals 9, then a equals plus and minus 3, correct? Because if I take square root of a squared plus minus square root of 9, a equals plus and minus 3. So that means off my 0, 0, because my vertex is at 0, 0, I would go up 3 and down 3. So those would be the ends of my major axis, or my vertices of my major axis. So now I could say, okay, so my vertices are at 0, negative 3, and 0, positive 3. So those would be my vertices. Now let's find our co-vertices, and they come from your b squared. So b squared equals 4 in this situation. So that's going to mean that b equals plus and minus 2, and I hope you can make that jump. Okay, so that means this is going to be on our, so our co-vertices are going to be on our x-axis here. So you're going to be at negative 2. Well, let's graph them. They were 2 away from the center, so left 2 and right 2 from the center. So that would be at negative 2, 0, and 2, 0. Right? And so we can go ahead and sketch this graph since we have the vertices. We haven't graphed the foci, but that's not really important. You don't have to put the foci on the graph. You just have to sketch the locus of points. But let's find the foci. Now we know that they're somewhere along the major axis. Okay? So let's find our C value. We know what A is. We know what B is, right? We know that A equals 3 and B equals 2. So let's find our C term, right? So C squared equals A squared minus B squared, or C squared equals 9 minus 4, right? All right, so that means that C squared equals 5. So C, if we take C squared equals 5, we'll take the square root plus minus square root of both of those. So C equals plus and minus the square root of 5. So we probably want to get an estimated value there if we were going to graph it. And I guess we could graph it just so we can look at it. So the square root of 5 is about 2.24. All right, so I'm going to just grab a different color pen here to do this. So they're on our major axis. So from our center, we're going to go up 2.24, so that would be what, about right there, and down 2.24, and that would be about right there. So how do we identify our foci? Our foci, look at our picture here. That would be at 0. Well, we'll do this one first. We'll do the bottom before we do the top. So that would be at 0, negative square root of 5. I'm using the exact value here. And then the other one would be at 0, positive square root of 5. I would like to see your exact answers, but of course you can't. It's hard to graph the square root of 5. You don't know where to put it, so you find its approximate value so that you can get it graphed. And there you go. So I've given you some problems to practice, and just be patient with yourself. And in fact, there's some really good short videos on Khan Academy. If you feel like you need a little more instruction, you can just go to Khan Academy and type in ellipses, and it'll take you to some short videos that are really good and some really fun little practice problems that'll help you to understand this concept a little better. So if you need extra work or need extra time to process all of this, I know that was a lot of information, I suggest you do that. All right? And so that's it for today. I will see you guys soon.